So in this lesson, as I mentioned before, we are going to dig deeper into the OS, operating system, and device drivers and device handling to understand how things works deep down in the operating system. So any computer system, any digital system has mainly 3-4 parts. The main part is a chip named CPU or central processing unit. The main job of CPU is to do certain simple operation like addition, subtraction, certain binary operation like AND, OR, XOR, NOT, etc. So CPU can't do any complicated operation like an image recognition or sending a packet to a network device or anything complicated. It can't do. All it can do is do certain operations and read and write data to different devices and memory. So that is the main job of CPU. Another important part of a computer system is called memory, which, just like the name says, it memorizes different binary digits. Then another part of a system is the disk. Disk is also a type of memory, but it is slower than the primary memory. So this is called primary memory, and this can be called secondary memory. Another difference between disk and memory is that when the computer shuts down or the power is off, the content of the primary memory, this fast memory right here, gets wiped out. While that doesn't happen for the disk. So the disk retains the memory, but it is slower than the primary memory. Now, a computer system has a lot of other devices connected to it. Say keyboard, say mouse, then graphics card. The graphics card is in turn connected to the monitor where we see things. This is a monitor. Then another very important device, especially from this training perspective, is called NIC card or network interface card. All these devices are in a way connected to the CPU. While they are not directly connected to CPU, but for the argument's perspective, we assume that they are directly connected to the CPU. Now there are other devices, USB devices. For example, if your device is having touch screen, it has a touchscreen device. If it is a phone, this computer we are looking at is a phone. It has camera, device to make calls in the phone, all that kind of special devices based on the type of computer. So the stuff we are discussing is common for every single type of computer, which includes phone, laptop, Linux, Windows, Mac, all kind of different computing platform. This is how it is designed. Now, this whole thing is called hardware. The one which I have drawn in red is hardware. Anything we can physically touch or see is potentially a hardware, computer hardware. Now, this is one side of this coin of the digital world. The other side of the coin is software. Remember, I told you the CPU can do only very simple tasks. It can't do any complicated things. It cannot understand an image. It cannot access Facebook. It can't do any complicated action like that. Now that is where the software comes into picture. Software is nothing but a set of instructions to the CPU. And in certain cases, it is instructions to the devices as well. So the most important software from a computing platform is concerned is called operating system. OS is the most important software. And more than often, it is the most complicated software as well. So the reason why I have drawn OS with the green outer rectangle is because all these devices which we are seeing inside is controlled by the operating system. It doesn't mean that it is inside the operating system. So operating system controls disk, CPU, memory, all hardware attached to it. Operating system makes the life of normal people like us to access these different computing hardware. So that is the main purpose of the operating system. So operating system abstracts the complexity of these hardware devices. For example, the user manual for the CPU is a document which is almost 5,000 pages. If you look at the training, which I mentioned, I'm showing that document. But just one device right here is a 5,000 page document. And I'm pretty sure not every single detail about the CPU is present in that document, because I have worked in such things. Almost always all the documents are incomplete. So all that kind of complexity is being abstracted from us by the operating system. Operating system has hundreds of thousands of lines of code to handle it. At the end of the day, they are nothing but set of instructions to the devices, CPU, disk, etc. So softwares are nothing but instructions, programs, just like the one we have seen, the Python program. So now what we can do is, let's have a look around and look at the operating system in this laptop right now. So this laptop you're seeing, this presentation, has an operating system, which is Windows operating system, Windows 11, in fact, at the time of this presentation. So we are going to look into the operating system a little bit more to see all these different things which is handled by the operating system. So in Windows, most of the devices you can see in something called Device Manager. So these are the different devices managed by this operating system. So there are so many different devices. If you click, you will understand what the device and what is the purpose of the device. For example, the disk drive. So I have these many disk drives connected to this laptop right now. And this is my display adapter. I have two display adapters. Display adapter is also called graphics card. So I have two graphics card. One is from NVIDIA and another is from Intel. And I have two monitors connected to this laptop right now. One is the default laptop which is coming. Another is the drawing tablet which I'm using to draw the block diagram you have seen. Now, this is our important guy. This is what this training is about, the network adapters. So I have these many network adapters, so many network adapters. Why this small laptop is having so many network adapters? Well, not all the devices are physical devices. When I made a comment, I said potentially. All the stuff you can physically touch or see is potentially hardware. It doesn't mean that all the hardware you can see and touch. There are software hardwares. It sounds confusing, but we will get to it. Basically, except this two network adapters, one is this and another is this, everything else is virtual devices. They are emulating a virtual fake device in the operating system. We'll get into all those details later, but these are the devices which is handled by the operating system. So this is not really a device. This is a CPU itself, but Device Manager is showing it as a device. So this is the processor or the CPU of this laptop. The memory also could be somewhere here, but memory as well as processor is not traditionally considered as devices, but everything else is considered as device. Now, what is this operating system? Where is the operating system present? Where we can have a look at the operating system. Like any other programs, operating system is nothing but files. Just a number of files. For example, our Python program. Our Python program was nothing but a file. So this listen server.py, it is a file. What is a file? File is nothing but a number, binary digits saved in the disk of this particular laptop. Similarly, operating system is also a program, no difference. It is also saved in the disk of this particular laptop. If you're using a phone, it is there in the disk of the phone, the storage. Now, can you see the operating system in Windows? Yes, you can. Let's see that. So most of the operating system components of Windows operating system is in the folder C Windows System 32. Although the name says System 32, it is common for 32-bit as well as 64-bit. So Windows traditionally keep all the operating system file in this particular directory. Now there are so many files here. As you can see, we are not going into the details of it. The important guy we would like to visit is the actual kernel. So the real kernel of Windows operating system is this particular binary, NTOS kernel.exe. So this is the single most important file as far as Windows is concerned. Again, Linux will have a file like this, Android, Mac, everything will have a file similar to this, or a group of file which will constitute the amount of logic in this file. Now, can this particular file handle all these devices here? For example, that file is written by Microsoft because it is Windows. So it is written by Microsoft Corporation. No one else in this world has access to the source code of this particular file right here. Only Microsoft has. Now, so many of these devices are from different companies. For example, my display adapter right here, that is from NVIDIA. It's a different company altogether. A company which is notoriously careful about the secret of the devices they have. They don't publish the secrets of these devices outside. So how those devices works inside an operating system like Windows? That is where something called device driver comes into picture. This file right here, the NTOS kernel.exe, which is the operating system, the Windows operating system, doesn't know anything about this particular device right here. Only the company named NVIDIA knows about it. In this case, only Intel knows about the secrets of this particular device. This device can have a lot of different capabilities, which is proprietary to this particular company. So what this company does is that they give something called device driver. So if you go to the properties of this particular device, you will see driver details or device driver details. So if you click on that, you will get to know what are the drivers which is responsible for controlling this device. So these are the device driver files for this particular device. A lot of files are there just for this particular device. Normally NVIDIA drivers are very complicated drivers. Similarly, our NIC card. So this is the actual physical NIC card which I'm using right now. It's a Wi-Fi adapter or Wi-Fi network adapter for this laptop right here. If I go to the properties, if I go to the driver and click on driver, I'll get the drivers of this particular device. As you can see, there is a special folder in Windows. They keep the drivers. See Windows System 32 drivers. Let's have a quick look at that particular folder. So it is a folder called drivers inside this folder. So this is where all the drivers for different hardware connected to this operating system. So operating system in turn connects or load these programs. They are again programs, nothing else. Just like our Python application. They are different programs used by the operating system to talk to these devices. So this is the driver of our Wi-Fi adapter. So there are multiple drivers for this device. So one is this, we have seen that, and another one is this. Let's have a look at this file. So this is the file right here. If I go to properties, I should see Intel. Previous one was from Microsoft. This is from Intel. The reason why it is from Intel is because that company knows most about this device. That company knows how to drive this particular device. What are the commands needed for the device to perform it correctly? So let's try to draw a quick diagram how the working of device driver. Suppose we have our NIC card here. So this is our Intel NIC card. Now the immediate software which is connected or communicating with the NIC card is the driver of this particular device, which is developed by Intel, that file we saw. And the OS, so OS is also a software, that's why it's green. OS will in turn communicate to this particular driver. Now this whole thing will be part of the kernel. Basically, device drivers are like a plugin to the operating system for a particular device. So OS is written by Microsoft and this is written by Intel. Only this program right here has the know-how about this particular device. What command you should pass to this device to get the bytes into this device or read from this device. This driver will also know how to communicate with the operating system. So operating system will have a standard interface to interact with the device. Basically, certain functions, just like the ones we have seen in our program. Standard function calls, that is what these arrows are. Documented function calls. Some of these function calls we will see when we look at the NDIS miniport drivers in this training to understand a little more about what we are talking. Basically in Windows, this type of driver has a special name called NDIS miniport. Don't worry about it now. For the time being, we need to understand the overall view of how a device is handled in an operating system. So this is true for Linux, Windows, Mac, everywhere. Intel has to write the device driver. The same logic it will be implementing for Linux if they want to make this device work for Linux. The driver will be different for Linux because these function calls right here will be different for different operating system. So that is how device driver works in any operating system. It controls the device and helps the operating system to handle the device. Now what happens if a device doesn't have device driver? Let's see that. Luckily in my laptop I have so many of them. So these are some of the devices in my system right now which doesn't have device driver. For example, I have a USB controller which doesn't have a driver. As you can see, it's not very happy about it. It is showing a question mark right here. So it says the driver for this device are not installed. There are no compatible drivers for this device. So I need to install driver for this particular device to connect to the device. Operating system is saying, hey, I don't understand how to communicate with this device. So you need to find a driver so that I can talk to this device. The language in which this particular device is being communicated to the operating system is not well understood. So there is a translator needed. And this guy right here is that translator. Now, why we are discussing a lot about device driver in this training? Because 90% of the network stack, in fact, I would say 100% of the network stack is implemented as device driver in an operating system like Windows. Same with the Linux. TCP/IP, network interface, card device, AFD.sys, the sockets we were using, all are different device drivers. So all the network protocols are implemented as device drivers. We'll get to it, but I'm giving you the reason why we are focusing on drivers. Now let's try to understand how our application comes into the picture. So we have this diagram in which operating system is here and the driver is here and the device is right here. Let's see that. So to conclude, we have seen some details about the OS and device drivers and things like that. Mostly we have seen privileged mode or the kernel. Kernel is nothing but the operating system and the drivers running inside. This is true for both Windows and Linux. Although we use Windows for everything, most of the things, almost everything we discuss is common for Linux as well. Now the kernel is the privileged mode. There is another mode called user mode or non-privileged mode. That's where our applications are running. For example, our server, our client, our web browser, which accessed the Google, all of them are running in non-privileged or application layer or application mode. Normally it is called user mode. Let's see that next.